All right, we are going to go over these notes again. I want to make sure that you have all the complete notes. We're going to go over front and back, so that way anybody that's struggling with their homework can go ahead and finish this. This is what we did in class today. We're not going to look at the graph that is required for this. We're just going to go through and rewrite the slopes again. All right, so the slope of line A, we remember from class, because we all got through that, was half. Slope of line B was also half. The slope of line C was 2. And the slope of line D was -2. Alright, so when we compared the lines, and again we did this all in class today, but when we compared the lines today in class, we said that lines A and B were parallel. One of the things I had you guys add to your notes in class today was that all parallel lines have the same slope, so you need to make sure you write that down somewhere. It's very important. As we compare lines B and C, we said that these lines simply intersected. They're called intersecting lines. They were not perpendicular because they don't create a 90-degree angle. They just simply intersected. So we said that when we compared the slopes of lines B and C, we noticed that these two lines had different slopes. So we said that lines with different slopes intersect. Okay, lines with different slopes intersect. Don't forget I asked you to change lines C and D here in your notes to lines A and D. When we look at the slopes of line A and D, we saw A was a half and D was -2. We said that these lines not only intersected, but they are more specifically perpendicular lines. And this is where it gets a little more complicated. Parallel's easy, they have the same slopes, will never cross, will never intersect. Intersecting lines, they cross and they just have to have different slopes. Well, perpendicular lines, if you look at these again specifically, I'm going to kind of go up here a little bit. We said that the slope of line A was equal to 1/2. The slope of line D was equal to -2. If you remember from class, we said that perpendicular lines, all perpendicular lines, have negative reciprocal slopes. Okay, negative reciprocal slopes, or opposite reciprocal slopes. Meaning that if you have the slope here of 1/2, okay, so the slope is 1/2, the opposite of that would be a negative, because it's positive now, so the opposite would be negative. And then the reciprocal would be taking the denominator, putting it on top, making it the numerator, and the numerator on the bottom, making it the denominator. So that would be -2 over 1 now. If you reduce this, it's -2. So again, this is what we wrote down in class. Perpendicular lines were negative reciprocal slopes. All perpendicular lines. Negative, and I'll write that here so you can read it. Negative. We also said it could be opposite, same terminology. Reciprocal. Spelled that wrong. So, negative reciprocal slopes. Two slopes together, negative and reciprocals of one another. The other way you can look at this, and again, it depends on how you want to look at it. I didn't tell this to every class, but I've taught this in before. If you multiply, this is kind of a side note, if you multiply your slopes, perpendicular slopes, or perpendicular lines, will equal -1. Put will -1. Will equal -1. So if I multiply the slopes of perpendicular lines, they're going to equal -1. So that's a way to test to see if lines are perpendicular or not. So for example, if we go back up here and we look at slope A is 1/2, and if I multiply 1/2 by slope B, slope D, which is -2, when I multiply those together, I have 1 times -2, and then 2 times, again this is a 1, 2 times 1 is 2, so then I have -2 over 2, which equals -1. That's just another way to check it. If that's confusing to you, don't worry about it right now. We can talk more about that later. It's just a way to check it. It's a good way to look at it quickly if it's perpendicular or not. Okay, so we covered all this in class. I just wanted to go ahead and put that on the notes anyways, so you can see it again, or if anybody was absent, we got that covered. Alright, so let's move on to the boxes on your notes page. And again, if you have these notes at home and you didn't finish filling them out in class, I would fill those out so you have them for later. I apologize for the glare, if you see that. Alright, so what we want to do is we're going to look at that box and we're going to make sure that, or we're going to actually find slopes that are parallel to the given slope, and we're going to find one that's perpendicular. So, again, a parallel slope, and again, this is the symbol for parallel. A parallel slope is the same slope. So here, if you're given 2/3, a parallel slope would be m equals 2/3. If I want a perpendicular slope, what I would have is m equals, remember, perpendicular, here's a symbol, and we're looking for opposite reciprocal. So what we would do here is we would take an opposite, this was positive, so now it's negative. Reciprocal, instead of 2/3, it's going to be 3/2. Okay? On -4, parallel lines, the same slope, right? So it would just be -4. These whole numbers are a little trickier. Okay? If I want to take -4, basically I'm looking at -4/1, so the opposite's now going to be a positive, so I'm not going to write the negative, so it's going to be positive, and then I take that 1, put it on top, and then put the 4 on bottom. So I would have 1/4. So the reciprocal of 4 is 1/4, opposite of negative is positive. Okay, then I have slope equals -1/4. Opposite of that, it's going to be positive. Flip it. I'm going to take the 4, put it on top of the 1. Well, 4/1 reduces down to 4. So the perpendicular to the -1/4 is 4. Okay, parallel to the slope of 2 is going to be just 2. It's going to be the same. Opposite reciprocal, instead of positive now, it's going to be a negative. Okay, instead of 2/1, we're going to have 1/2. Again, it's the same thing as this concept up here, where this was actually 2/1. Right, that we flipped over. Finally, an undefined slope. If we want a parallel line, we need another slope that's undefined. Okay? And if you remember undefined slopes, we're going to look at this in two different ways. An undefined slope, an example of that would be something like 5/0. So if we take something like that, an example like that, and we say, okay, let's take the opposite reciprocal. So we would come over here and say, okay, the opposite would be negative. The reciprocal would be 0/5. Well, if you stick that in your calculator, 0 divided by -5, or -0, which there's no such thing, divided by 5, you would end up with the slope of 0. That's how you would kind of do that mathematically if you want to do it mathematically. But if you want to think about this logically, think about this. Undefined line is a vertical line, straight up and down. Well, how do I get a perpendicular set if I have a vertical line straight up and down? Well, the perpendicular set's going to come from a horizontal line. Well, we should know from our past classes that a horizontal line has a slope of 0, period. So I would just put m equals 0. I wouldn't have to go through all the math if I remember the slopes. Okay. Lines that are parallel, lines that are parallel have slopes that are, and we already talked about this earlier, we would just write the same. Lines that are perpendicular have slopes that are opposite or negative. Reciprocals. Okay? And then here, on this bottom column, what we're going to do is we're going to actually write equations, okay, of lines that are parallel and a line that is perpendicular. You can make up any equation you want. It's not that difficult. Well, the only thing I need to know about the parallel is, again, this is same slope. As long as it has a different y-intercept, it's going to be parallel. So down here, I would write maybe y equals, well, what's my slope? 4x. This is the key. So y equals 4x. And I can put any number there. Any number I want. I can leave it like that. Y equals 4x is parallel to y equals 4x minus 3. But I'm just going to put a number there. Let's just say 15. It doesn't matter. You can put any number you want right there. Okay? Perpendicular. Again, we're dealing with opposite, reciprocal. So I'm going to have y equals. Go back to my slope. My slope is 4. The reciprocal of 4 is 1 over 4. The opposite of positive is negative. So I have y, at least y equals negative 1/4 x. This line right here, just that line right there, goes to the origin. That line right there is perpendicular to this one. Okay? But I can put any y-intercept I want in there. So if I want to put a y-intercept of 5, I can do that. So y equals negative 1/4 x plus 5. If you're at home and you want to do y equals negative 1/4 x plus 27, it's all the same. It's all the same. Okay, let's do the next one. Y equals negative 1/8 x. Well, if I want the parallel lines, I need to have the same slope. So y equals negative 1/8 x. Now, all I have to do is make sure it's not plus 2, because plus 2, if I write that again, I'll have the exact same line. Those will not be parallel. Okay? So, I just change the y-intercept to, I'm going to do negative 54. Why not? So y equals negative 1/8 x minus 54. That line is parallel to this one. They're far apart from each other, but they are parallel to each other. Perpendicular, again, I'm looking at the opposite reciprocal. Y equals, the opposite's going to be positive in this case. Flip it, I'm going to have 8 over 1 will be my slope. But if I reduce that, 8 over 1 is just 8. So I'm going to have y equals 8x. I can use any y-intercept I want. Okay, as long as it's not, well, even 2 would work. I'm just going to go ahead and be lazy and say minus 54. Why not? It doesn't matter. Okay? The last one, they try to trick you here. We have y equals 7. What kind of line is y equals 7? Okay, you should know that y equals 7 is a horizontal line. Because there is no value of x, or there's no x there, you know that 7 is the y-intercept, and that's it. If there's no x, that means the slope was 0. Okay? That means the slope was 0. Now, with that being said, if I want a parallel line, I just need another equation that has a slope of 0 and has a different y-intercept. Well, a slope of 0 is simply going to be another horizontal line. Any other horizontal line could be like y equals 9. That's horizontal. It has the same slope.